video of today, 8.4, Impact of Organized Data. In this part, I want to use a concrete example to show you how important is the organized data. But for this problem, I need about 2 10-minute videos to complete this topic. But I only have 10 something minutes left, so I can only do the first video. The second video I will put in the part B. So part B, the first video, I want to complete this problem first. Then we start new problem. Yeah. All right, so let's start. First, let's look at the question. Our problem number 5, element uniqueness problem. From the name, you can see we want to check if a given array has this property. All the elements are unique. That's the problem from the title name. Given an array. In this way. Question, how to check if all the elements are distinct? Think about, yeah. The problem is not that hard. Think about how to solve it. In your mind, you can try a little bit. Yeah. Then, so look at my solution. To do it, I want to use 2 methods because we want to do comparison. Which one is better? Okay. In method 1, I do not use organized data. Method 2, I will use organized data. So we can compare, is it better to organize the data or not? Yeah, so that's my goal in this example. Method 1, do nothing to organize data. The reason is simple, because we don't want to pay the cost to organize data. When you organize data, you need to pay some cost, right? It's true, you need to pay some cost. And here, we want to save that cost. Okay, yeah, so yeah. Here, so let's look at one example. Given array like this. Now we want to check if each element is unique in this array or not. Okay. Yeah. Here, let's check if the first element appears somewhere in other places in this array. When we check it, we need to n-1 comparisons, right? We need to look at the remaining elements, n-1 comparisons. If it is the same as one of the elements in the remaining part, we stop because we get the answer. It does not have the property that all the elements are distinct. It does not have this property. So we get the answer, so we stop. If we cannot find, if the first element, if after n-1 comparisons, we cannot find any other element has the same value as the first one, then we continue to check the second element with the remaining elements, right? In that case, we need n-2 comparisons, and so on. Keep doing, checking, and so on. Okay? Then this one, only one comparison. Because the last one, we don't need to do comparison. The last one, nothing to compare, right? So here you can see the total number of comparisons, adding these numbers together. So very simple, right? So that's the method 1. So very simple. Yeah. The reference of this problem section 2.3. Yeah. All right. Next, we do analysis of efficiency. Yeah. How many basic operations here, number of comparisons do we need? The best case and the worst case. All right, the best case and the worst. The best case, when the first two elements have the same value, that's the best case. Okay? CB of n equals 1. We only need one comparison, we can find the answer. That's the best case. All right. The worst case, then the last two elements are the same. So you need to go through all the possible comparisons, and the last comparison gives you the answer, right? Yeah, gives you, they have the same value. Then you need to pay this many comparisons. Yeah. So the best case, the worst case. Yeah. All right. Then one question I want to ask you here, average case efficiency. Usually average case efficiency is harder than the best case and the worst case. Average is much harder. Yeah. So here I'd like you to try first. Try by yourself first. Okay? Yeah. Later at some time, I will show you how to find this average case efficiency. Okay. All right. So next, we want to look at the method number 2. Okay. Yeah. For method number 2, we pay some cost to organize data. When you organize data, you need to pay. We're willing to pay and see if we can do better. Method number 2. So let's do it in this way. Because when we organize data, we treat it as investment in data structure. Data will be useful. We expect that investment will pay off later. So we are willing to do that. Okay? Yeah. So what kind of investment we will pay? We will do, we sort the array first. We just sort the array. Given array, we sort it first. Okay? Yeah. How much cost do we need to pay when we sort an array? Here, we like to use the best sorting algorithm. Not the sorting algorithm, selection sort. Selection sort is very bad. Very slow. So we don't like that one. So we want to choose one that is really good. Yeah. If at this point, we don't know what's that. Yeah. Later, we will learn more sorting algorithms. So here, I just tell you, we pick the best one in the market. Then we will get n log n efficiency, running time efficiency, n log n. Yeah. So that's the initial cost we need to pay. The first cost, organizing data, we need to pay that much cost. Yeah. But why is this one? We will have a lot more discussion later. Yeah, so don't worry. So we will spend a lot of time in this class to find the answer. Yeah. All right. Next, how to check if any element is repeated in an ordered array. This time we have an ordered array. Now, when we check the uniqueness property, it is much easier. Yeah. So let's do it. Yeah. Now we can assume the array elements are arranged in increasing order. This time, we just do a simple observation here. When we check uniqueness, we only need to compare two adjacent elements. Because if two elements have the same value, after we solve the array, they will be, there will be two adjacent elements that have the same value, right? Yeah, same value, sorting. They have to be, connected in a block. Yeah, because you may have multiple elements that have the same value, right? So there is a block of elements with the same value. You will have that part. So this is the key observation. But you just check two adjacent elements. If they have the same value, then you find the answer. Okay, all right. To do that, it is very simple. We use a for loop and we just compare two adjacent elements. If they are the same, return false. The false means the elements are not distinct in this array. True means the elements are distinct in this array. Then, number of operations. In this for loop, you can see n-1 operations. Now, you can see we need to combine the cost. These two, because we do operations two places. So we need to put them together. So the final running time efficiency function n log n plus n-1. Okay? Yeah. All right. The first method, this one. The second one, that one. Our next step, we need to compare which one is better, which algorithm is faster. So I need to use another 10-minute video to explain that part. But let me finish this C.4 and our, not C.4, right? 8.4. Yeah, 8.4. Then the part A right here.